You're listening to the N2K Space Network.
Cyber threats are more sophisticated than ever. Passwords, they're outdated and can be cracked in a minute. Cyber criminals are intercepting SMS codes and bypassing authentication apps. While businesses invest in network security, they often overlook the front door, the login. Yubico believes the future is passwordless. YubiKeys offer unparalleled protection against phishing for individuals, SMBs, and enterprises. They deliver a fast, frictionless experience that users love. Yubico is offering N2K followers a limited buy one, get one offer. Visit yubico.com/N2K to unlock this deal. That's YUBICO. Say no to modern cyber threats. Upgrade your security today.
Today is March 18th, 2025. I'm Maria Varmazes, and this is T-Minus.
T-Minus 20 seconds to LOS T-Dress. Go for deploy. Roger, roll.
Rocket Lab successfully deploys 5 satellites for Kinéis, completing their IoT constellation.
4.
Pixel's Firefly satellites have captured the world's highest resolution hyperspectral images from LEO.
3.
China's Galactic Energy successfully launched the Ceres 1 rocket, putting multiple satellites into sun-synchronous orbit.
2.
Pangea Aerospace raises 23 million euros in a Series A round.
1.
Crew 9 undocks from the ISS and is heading back to Earth. Today's guest is Brad King, CEO and co-founder of Orbion Space Technology. We'll be discussing in-space propulsion and vertical integration, so stick around for more on that later in the show. Happy Tuesday, everybody, and it's a little premature, but hopefully by 5:57 p.m. today, in Florida, we'll be able to say welcome home to Crew 9. The SpaceX Dragon capsule carrying the 4-person crew undocked from the International Space Station just after 1 a.m. this morning to begin the 17-hour journey back to Earth. Crew 9 Commander Nick Hague and cosmonaut Alexander Gorbanov are joined by Butch Wilmore and Sunny Williams, who have spent the last 286 days in space. As we're sure you remember, the mainstream media likes to remind us, they were originally planning to spend 8 days in orbit. 16 hours after they initially undocked from the ISS, the flight plan calls for an automated 7.5-minute deorbit thruster firing starting at 5:11 p.m. to slow the ship down for re-entry. After a 27-minute freefall, the spacecraft is expected to fall back into the atmosphere for the final 12 minutes of the descent, making a parachute-assisted splashdown off of Florida's Gulf Coast a few minutes before 6 p.m. A SpaceX recovery ship will be stationed nearby to haul the spacecraft on board. And we really hope, the splashdown marks the end of the abandoned and stranded headlines that we keep reading with clenched teeth when referring to Sunny and Butch. Regardless, welcome home to all the astronauts. European startup Pangea Aerospace has raised 23 million euros in a Series A funding round. The company, based in Barcelona and Toulouse, specializes in the development of propulsion systems for the space industry. Pangea says its propulsion systems enable more efficient and reusable rockets using sustainable propellants. With this funding, the company plans to accelerate its expansion in the European market, aiming to grow its private and institutional customer base. Pangea was selected several months ago by the European Space Agency to define the very high-thrust rocket engine for future European reusable launchers, and is also participating in various projects related to the development and integration of its Arcos engine and the reuse of upper stages using aerospike technology. In addition, Pangea is collaborating with ESA and a consortium of companies to design, manufacture, and validate key technologies for the next generation of large European rocket engines. Moving over to China now, and Chinese commercial space company Galactic Energy has successfully launched its Series 1 rocket, putting multiple satellites into a sun-synchronous orbit. The spacecraft lifted off from the Jiuquan Satellite Launch Center in northwest China on a mission dubbed Auld Lang Syne. The rocket delivered at least 5 satellites to orbit, including the Yunyao 1 5560 and the AirSat 06 and 07 satellites. Yunyao 1 is a series of commercial meteorological satellites developed by Tianjin-based Pangea Aerospace. The company aims to form a constellation of 90 satellites. The recently launched satellites are equipped with Global Navigation Satellite System occultation detection payloads to collect atmospheric temperature, humidity, pressure, and ionospheric electron density data. Pixel's Firefly satellites have captured the world's highest resolution hyperspectral images from LEO. The spacecraft launched in January of this year aboard SpaceX's Transporter 12 mission. The 3 Firefly satellites have sent images captured at a 5-meter resolution across 150-plus spectral bands with a 40-kilometer swath width. The released images highlight unseen details of 3 areas, one from each satellite. The images shared show the River Ganga in India, Salum River Delta in Senegal, and Sundarbans mangrove forest in India. They have captured more detail than traditional satellite images and span a comprehensive range of spectral bands. Pixel says the images can assist agricultural operators, climate monitoring agencies, mining companies, and disaster response teams. Space really does provide incredible insights for us here on Earth. And as we mentioned in yesterday's show, Rocket Lab had yet another launch overnight. They successfully launched their Electron rocket, deploying 5 satellites to low Earth orbit for French Internet of Things constellation operator Kinéis. The mission was the 5th in a 5-launch deal with Kinéis that has seen Rocket Lab deploy a complete constellation of 25 IoT satellites in less than a year. The High 5 mission lifted off from Rocket Lab Launch Complex 1 in New Zealand at 14:31 local time, successfully deploying 5 satellites to a 650-kilometer low Earth orbit. And that concludes today's Intel briefing. Head to the selected reading section of our show notes for updates from some of the deployments on board the Transporter 13 mission, which lifted off last Friday. Hey T-Minus crew, if you are just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. Also, please do us a favor, share the intel with your friends and coworkers. Here's a little challenge for you. By Friday, please show 3 friends or coworkers this podcast. A growing audience is the most important thing for us, and we would love your help as part of the T-Minus crew. If you find T-Minus useful, please share it so other professionals like you can find the show. Thank you so much for your support, everybody. It means a lot to me and all of us here at T-Minus.
And now, a brief message from our sponsor, DropZone AI. Is your SOC drowning in alerts, with legitimate threats sitting in queues for hours or even days? The latest SANS SOC survey report reveals alert fatigue and limited automation are SOC teams' greatest barriers. DropZone AI, recognized by Gartner as a cool vendor, directly addresses these challenges through autonomous recursive reasoning investigations, quickly eliminating false positives, enriching context, and enabling analysts to prioritize real incidents faster. Take control of your alerts and investigations with DropZone AI.
Our guest today is Brad King, CEO and co-founder of Orbion Space Technology. And I started off by asking Brad about how he got involved in space.
I knew from a little kid what I wanted to do, so that guided every decision and made it pretty easy. I went to University of Michigan and got a bachelor's, master's, and PhD in aerospace engineering. Coming into my PhD program in the early 90s, the Soviet Union had just recently collapsed, and they were looking to capitalize on all the technologies they had. One of the technologies they had was a Hall effect thruster, and it was a spacecraft propulsion device, and the Western Hemisphere didn't really know about it, but it was curious enough that NASA and DoD sent a team over to now Russia to poke at this thing with a stick. Turns out it was pretty impressive. So they brought a couple of them back to the U.S., and that's where I entered the story. As a new PhD student, I happened to inherit one of these devices and did my doctoral work on it. So that kind of started my journey working on space propulsion before anybody really cared. And then fast forward to the mid-2015s, all of a sudden this weird technology that I happen to be an expert in was going to have its moment in the market. So I took a swing at it, and here we are.
Okay, that's awesome. I love that. And Hall effect thrusters are something that I am vaguely familiar with. Can you give me sort of the, if one can, on your a big part of your life's work, give me sort of a what is that and how does it work? If one can summarize.
Yeah, sure. They're pretty simple. They're a rocket engine, and by a rocket engine, what that means is you throw mass in one direction to make the rocket move in the or the satellite move in the opposite direction. So there's nothing magic about them. What is great about them is they're very fuel efficient. They can do a lot of thrusting for a small amount of propellant. And then that leaves more room on the spacecraft for things that make you money. If you have a giant fuel tank on your spacecraft, that's not great. So Hall effect thrusters are a fuel-efficient rocket engine, and they have nothing to do with launching the spacecraft. The satellite's got to get into orbit on a Falcon 9 or something like that. But once it's in orbit, it's got maneuvering to do. It needs to raise its orbit, needs to dodge collisions, it needs to deorbit, and that's what the Hall effect thruster is used for.
Right, and now that we're in this phase of things in space where we're having much more maneuverability, we're talking about ISAM. I imagine. I hear Hall effect thrusters talked about quite a bit. And again, I'm not a propulsion person, but it makes a lot of sense where they fit into sort of the bigger picture here.
Yeah, they're really attractive. So there are kind of two families of propulsion. There's traditional chemical propulsion, and it's called chemical because you burn something. You take a fuel, you burn it, you release its chemical energy, it shoots a flame out the back and makes thrust. Those systems can make very high thrust, but they're not very fuel efficient. On the other hand, are electric propulsion systems. They are very fuel efficient, but very low thrust. And you can't have both. Isaac Newton has a sense of humor, so you can either have high fuel efficiency or high thrust. Now, among the low thrust but fuel efficient devices, the Hall effect thruster has the highest thrust. So it's kind of distinguishes itself there. So it's got a really good balance of decent thrust and high efficiency.
So I'm wondering, how does that bring us to where you are at today? I'm curious. Tell me a bit about your company.
Yeah, it was, like I said, early 2010s or so, and we heard all these stories about OneWeb and Starlink and all these companies planning to launch hundreds or thousands of spacecraft, which at the time sounded fantastical. And here we are, having exceeded that. And what I was able to realize, having this weird expertise in Hall effect thrusters, is that all of these satellites were going to need Hall effect thrusters. They probably didn't know it yet. And worse, they didn't know there was nowhere in the world to buy these things for small satellites. So I thought, oh, holy cow, this thing I happen to know how to do is going to have a demand. So we, with my co-founder, formed Orbion and said, we need to have small satellite Hall effect thrusters ready to buy in about 5 years. So it was, all hands on deck. Let's go as fast as we can. And that's what we did. We merged with the demand.
Yeah. So what has that been like? Tell me a bit about, have there been supply chain challenges? I mean, how have you been able to scale with, the market as it's been growing?
It's been incredibly hard. And I tell people, if I had known it was going to be this hard when I started, I might not have started. But now that we're in it, we keep going. And so my background being technical, in university laboratories, we built tens of Hall effect thrusters with PhD students, and it's not that hard to build one in the lab. What's really, really hard is to build one that can fly in orbit and then build hundreds of them that are exactly the same. That has been a challenge of Orbion. The rocket science was rather straightforward, but the manufacturing has been a huge challenge. So we're there now, but it was really hard to get here.
I'd love to hear more about that, to be honest, because I think that's really interesting. Because again, we many times we think maybe the older model of how space or manufacturing for space has worked. It's been very boutique. We're beyond that now. We're well beyond that. So I think that the maturity of the market meeting you where you are at right now is a really fascinating place to be. And I mean, are we at the point now where people can just go, yes, I want that. I'm going to go pick that off the shelf? I mean, is that where we are?
We're pretty close. There's always timelines involved and its supply chain. But for instance, with our product, we've got a spec sheet. It's an off-the-shelf item. We tell you what its performance is. And if you want one, we can deliver it to you in maybe as soon as 4 or 5 months if you want low quantities. But if you want more than that, it's more like 10 or 12 months to get the supply chain wet. But it's essentially buy off the shelf now.
Wow, that's incredible. To me, just thinking of how things used to be many, many years, just to talk about things in a matter of months, it's quite amazing that we are at that place now. So in sort of a bit of inside baseball for the listeners here, part of the pitch, I think, for our conversation today was of talking a bit about vertical integration. And I'm curious, I wanted to hear your thoughts on what your thoughts are on that specifically. Like, where are you going with thoughts on vertical integration for the satellite market?
Yeah, it's a good question. I would start with nobody wants to go vertical. If you can buy something on the market and it can show up on time and it has a good price, that's what you want to do. That's much easier. I always, with tongue in cheek, talk about the CEO Serenity Prayer, and it says, "Please God, give me the money to buy what I can't build, the engineers to build what I can't buy, and the wisdom to know the difference." But we end up getting pushed into vertical generally because we've been hurt by a supplier. Somewhere we've identified a buy decision that we made and it didn't work out, and we thought, "Oh my God, we can't do this anymore." So we are largely vertical right now. We do everything except printed circuit boards. And we do that not because it was our choice, but sort of because of necessity. So I think a lot of other companies have been driven there as well. When the supply chain is not very mature, you don't want to rely on them. Now, we might not be better than our suppliers, but at least we can control it. And the knowledge is as important as the convenience.
Do you see the supply chain domestically reaching a greater point of maturity where maybe you can de-verticalize at some point, or is it just having that control just so crucial to you that it doesn't? Maybe it's secondary.
That's a good question. My opinion, in the space industry, our volumes are always pretty small. We're not making iPhones or F-150s. Even though the space market is growing fantastically, we're talking about thousands of units a year, not millions. So within that, for instance, if we have a key widget in our supply chain, there's never going to be 10 suppliers for that widget that we can compete or rotate through. So I think there's always going to be a decent amount of vertical integration just because of lack of supplier diversity.
And what does that mean for workforce too? I mean, you have to have, and this is a challenge I've talked to many people about, having the expertise in-house to understand, are the raw materials coming in? Are they of the grade that you need for these certain components that you're building? I mean, that's very specialized expertise given the space industry. Are you finding that, or is there a pipeline issue?
The expertise is out there all the time, but there's an inertia factor to spooling up. For instance, early in our development, there was a specialized valve that we needed, and we didn't have any interest in making them. But after 2 years of searching, we found there was no reliable source for them. And then we kind of rubbed our hands and went, "Oh my God, this valve is really complicated. What are we going to do?" And one of our VPs actually looked at me and said, "Brad, you're making plasma thrusters and you're afraid of a damn valve?" And I said, you're right.
It's always
valves. You're right. So why don't we get smart enough to do this ourselves? So there was an inertia factor. We had to learn. And that was kind of time spent on the treadmill. But now that that's behind us, we're really happy we brought it in-house. The expertise required to design the valve was nothing special. We just had to put the team together and bring it in-house.
That makes sense. Okay, I could totally see that. I'm very curious about sort of your long-term vision for your company. Again, we're at a fantastic time in the in terms of what's happening in the space market, a lot of exciting developments. I'm very curious about your thoughts maybe 5-10 years from now.
Yeah, I mean, our ambitions are pretty simple. We simply plan to take over the solar system, starting with this planet. So
great.
That's what we get up and pledge ourselves to every day. So right now we're working on propulsion systems because that is a crucial bottleneck in the supply chain.
We'll be right back.
Tired of investigation tools that only do one thing at a time? Spending more time juggling contracts with data vendors than actually investigating? Maltego changes that for good. Get one investigation platform, one bill to pay, and all the data you need in one place. It comes with curated data and a full suite of tools to handle any digital investigation. Connect the dots so fast, cybercriminals won't even have time to Google what Maltego is. See the platform in action at maltego.com.
Welcome back. I wanted to give a shout out today to a great piece in the Space Review by Dennis O'Brien called ATLAC and the Early Emergence of Lunar Governance. It's a really comprehensive article about legal governance of the moon. Highly recommend you give it a read, and the link is in the show notes for you. Now, ATLAC is the Action Team on Lunar Activities Consultation, which, if you haven't heard of it, don't fret. It's new on the scene. It was just created by the United Nations Committee on Peaceful Uses of Outer Space, or COPUOS, this past February. And ATLAC's goal is to try and fill the moon-sized hole in the 1967 Outer Space Treaty. Who could have imagined in 67 the reality of what we're looking at for the moon and cislunar activities today? And well, they couldn't. So a lot was basically left to imagination for future generations to figure out. And that time is now, and perhaps one could argue that time was yesterday. Among the topics that ATLAC is taking a look at is avoidance of harmful interference, information sharing, protecting the lunar heritage and special interest sites like the first footprints on the moon, and general standards and operational procedures on the moon, like debris mitigation, safety, that kind of thing. There is a lot of work, overdue work, needing to be done here, but the action team is a step in the right direction at least. Working with the Space Resources Working Group, ATLAC has until 2027 to chart a way forward here and create either a new cooperative lunar agency or governance agreement. And we look forward to seeing what happens next. That's it for T-Minus for March 18th, 2025, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K senior producer is Alice Carruth. Our producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I'm your host, Maria Varmazes. Thanks for listening. We'll see you tomorrow.
T-Minus.
Hey everybody, Dave here. Have you ever wondered where your personal information is lurking online? Like many of you, I was concerned about my data being sold by data brokers. So I decided to try Delete Me. I have to say, Delete Me is a game changer. Within days of signing up, they started removing my personal information from hundreds of data brokers. I finally have peace of mind knowing my data privacy is protected. Delete Me's team does all the work for you with detailed reports, so you know exactly what's been done. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners, Today, get 20% off your Delete Me plan when you go to joindeleteme.com/N2K and use promo code N2K at checkout. The only way to get 20% off is to go to joindeleteme.com/N2K and enter code N2K at checkout. That's joindeleteme.com/N2K, code N2K.